There are a couple more things I want to point out to look out for when we're factoring out the greatest common factor. The first is if the first term in your polynomial is negative, then you need to factor out a negative greatest common factor. Let me show you an example of this. If we have negative 3x squared plus 6x minus 33. We do not like for this first term in our polynomial to be negative. So we're going to take care of that when we factor out our greatest common factor. When we take a look at our numbers, we see that all of these are divisible by 3. So we know we have a greatest common factor. Normally we would factor out a 3, but because this first term is negative, we want to factor out a negative 3. That way, we are left with a polynomial that has a positive leading coefficient in case we have to factor further. That will make our life easier. So when I divide each of these by negative 3, that's going to leave x squared. When you divide a positive 6 by a negative 3, that's going to leave negative 2x. And when you divide negative 33 by negative 3, that's going to give you positive 11. So you see now our polynomial that we're left with, once we take the greatest common factor out, has a positive leading coefficient, and that's going to help us as we progress into more factoring. Let's look at one more like that. Now, you see that the first term is negative or has a negative leading coefficient, an understood -1. We don't like that. We want to take care of that. But you might look and you might say, well, I don't see a greatest common factor here. I don't know of any number that I could factor out. Well, keep in mind that you can always factor out a +1 or a -1. Most times factoring out a +1 really won't do anything for us, but in this case we can factor out a -1, and that will at least get rid of the negative in the front of the polynomial. So if you divide all of these terms by -1, you're going to have positive x squared, positive 6x, and -7. Dividing by -1 really just changes your signs. But what's good about this is now we have a polynomial with a positive leading coefficient, and that will help us as we move forward. One other special case, you can also have a greatest common factor that is a binomial, which looks a little weird, but it certainly can happen and will happen. For example, here I have 2w times x plus 3 minus 5 times x plus 3. And what you might notice here is that you see we have an x plus 3 here and an x plus 3 here. I kind of want you to think of this as one big thing and this as one big thing. All right, and what do these two things have in common? They have an x plus 3 in common. So they have a greatest common factor of x plus 3. And so we can factor out an x plus 3. Now, because x plus 3 is a binomial, when we pull it out to the front or factor it out, we want to keep parentheses around it. If I take an x plus 3 out of this first group, that's going to leave me with a 2w. If I take an x plus 3 out of this second group, that's going to leave me with a minus 5. And there I have factored out the greatest common factor, x plus 3. Let's do one more like that. 8y times a plus b plus 9 times a plus b. Okay, once again, I want you to think of this as one big thing and this as one big thing. All right, and what do those things have in common? They have an a plus b in common. A plus b is a binomial, so let's keep it in parentheses. That is our greatest common factor, so we're going to pull an a plus b out to the front or factor out an a plus b, keeping it in parentheses. If we take an a plus b out of this first group, we're left with an 8y. If we take an a plus b out of this second group, we're left with a positive 9. And that is how you factor out a greatest common factor that is a binomial.